Guys, Shane here, Windows Machine Shop. Welcome to the shop. Welcome to the channel. I was in the middle of working on a project here. I know I haven't posted in a while. I've been super busy. I apologize for that. Just, life gets in the way sometimes. But I have a pretty cool job. It's taken me a little bit of time to figure out, and I thought I'd share that with you real quick. And also, there's a few new machine tools moving around here. Things are happening. The other reason that I haven't posted in a while, I've been moving this shop around and trying to organize this god-awful mess for months. It's yeah, I'm sure you guys know it's kind of tight in here, and the weather doesn't always cooperate, and pretty much everything needs pulled out with the forklift and put back in, and it's yeah, super fun. It's super fun, but yeah, I've been busy. Anyhow, today I got a shaft for a wheel loader. It has a helical gear on the one side that drives a gear reduction that runs the hub. The other side has involute splines. The helical gear is the part that I wanted to share with you. I don't go super into depth, but I do go a little bit. I don't know. There's some good pointers and stuff, and then I'll show you what that job was worth, which I think is pretty cool. I think you guys will think is cool, and it may be not a monetary thing. It's probably going to cost me money. Oh well. I'm going to spin you around. I'm going to show you what I got going on real quick before this phone dies, so I can try and get you guys a video together. Alright, hang tight. Alright, you're turned around. So this is the shaft in question. Okay, fortunately, there's another side, and I was able to get that for, my major diameter, which I actually figured out with this and the hub gear, which was unscathed. I second-guessed myself for probably 2 months on this thing, and I shouldn't have, because the first cutter that I had ordered, which was a 30-degree module 5 cutter, is, for all intents and purposes, the correct one. But the math wasn't quite adding up, so I don't know, and I wasn't 100% sure on the actual sizes. So, but this is what I got. Some bonehead ground all the teeth off. They pulled this thing out. They took the time to pull this thing out, which meant that they pulled the hub, because it all has to kind of come out together, and that the big bull gear that mates with this has to come out to clear the tapered bearing that's interference fit onto this. So they pulled it out and ground it down to send this thing to an auction to make it roll, and they really screwed a guy over, because this is something you can't buy. This is something you have to make, and I just happened to be the lucky son of a gun that got the task to do it. But yeah, I think we figured it out in this one, and I'll show you guys a little bit more about cutting some helical gears. If that sounds interesting, or you want to see the cool new acquisition to the shop, then you should definitely stick around and watch this. Alright guys, just bringing you over here real quick. I was working on this helically splined shaft, well, helical gear on one end. A couple different features for holding bearings and snap rings and seals, and that's going to be splined on this side. It's an axle shaft for a wheel loader. Thought I'd show you guys some of what's going on. I was gonna make a video with all the math and everything, and I just didn't. It's basically the same as the last one. Couple key things that are different. These are 30-degree pressure angle teeth on this particular shaft. It's metric, and the one that I'm duplicating was really no help because somebody ground all the teeth off. So yeah, basically we're here, and we do have another shaft off of the other side. Is how I ended up confirming. I actually second guessed myself for well over, I would say, 2 months on the, the module of the gear tooth, the helix, the OD, basically using your common equations for that kind of thing. At some point, all I had was an OD, so basically number of teeth plus 2 divided by the outside diameter to get a rudimentary diametral pitch, which is easily converted to a metric module by dividing your 25.4. So I went through that. I second guessed myself about 1,000 times. Finally got the other shaft for the other side and realized that I was pretty much right the first time. So this is kind of where I've been, and this shop has been a mess. I've had lots and lots of work to do at my day job and machining. I just haven't had a whole lot of time to pick up the camera, so I sincerely apologize for that, but I'm trying to get back on it now. So a couple key points with these. The best way to measure this is a really odd gear profile, so I used the other side to get my OD, my ID, but realistically the thing that counts in this situation is the depth of the pitch circle of your tooth profile, and the only way to measure that on a helical gear is by using a ball bearing, because then you only have one point of contact on either side, and you need to distance how far at what part of the gear you're at and match it. This being an odd number of teeth, which is also kind of weird, and it's unconventional to be cutting. This is a 9-tooth gear, which is why the cutter's so obscure. It also probably has a lot to do with why they have 30-degree pressure angle for the teeth. So yeah, it took a whole lot of math, but back to what I was saying. Yeah, you just find your tooth being an odd number, and there should be a cut, on the direct opposite side of that, 180 degrees from it. As long as you have the same distance, you're going to use a ball bearing, and that'll determine if your tooth is set in the right place, if that makes any sense at all. But you can't really use pins or thread wires or anything like that on a helical gear. So yeah, it definitely took a little bit. I just measured that, here to here with a ball bearing, and determined I need 95 thousandths more depth of cut, which should be about right. Which is another thing that's weird about this. That's a module 5 cutter, which is it's the same mathematically as a 5 diametral pitch cutter, which should be about 500 thou depth cut, and these are only somewhere around 355 to 360, plus maybe a hair where the clearance, which is more in the realm of a 6 diametral pitch, I'd say. or I want to say maybe 4.5 module. Don't quote me on that. So it's kind of different. It's kind of weird, but at the end of the day, my goal is to match the gear tooth profile, the depth of the pitch circle, and have adequate clearance to make this thing work. It's kind of a situation where somebody bought a wheel loader at an auction, kind of got screwed in. Now we're just trying to make it go, trying to make it run. But I took so long making it because I want it to be as perfect as I can possibly get it. I wanted to go through, run the numbers as many times as it took, and I want to be able to cut something that's going to last, not just to get it to the next auction. I want the guy to be able to use this thing. So that's what we're working at, and that's why this thing has been procrastinated on skillfully. Skillful procrastination, I guess. So I guess I'm set up. I absolutely am set up, and I'm gonna make the first of the, I've made 2 passes to here, 225,000 passes. I added the 90 and I left 5 for a cleanup cut. So that's what we're gonna do. Which is super fun because I'm using a 72 hole plate on a 5-to-1 head, which translates to having to jump 40 holes, you know, for each division. So super fun, and it has me cross-eyed counting the holes and triple checking so I don't screw it up, because I only have this one piece of 4340, which is great steel for axles. In this situation, perfect. And I can't screw it up, so I'm probably gonna get cutting on these, and I will probably bring you back maybe on the last cut or so. I'm not gonna waste a whole bunch of time with it. Might give you a little video of cutting into this one, taking the 100th thou cut, but it's a really slow go, so I'll probably end up fast forwarding it after a minute. So you guys don't have to spend hours watching this thing work like I have to. So hang tight, I'll bring you back. Alright, so that's one nearly fully cut tooth. Okay, and they do cut a little bit out here. Not a big deal. If you look at the original, it has the gear teeth run into this. This is just a landing that a bearing presses onto. That's how they did it. That's how we're doing it. Don't look too bad. I could honestly come out a hair further. I think I will on the final pass. You can see it kind of hooks up here because it's not all the way out of the cutter. But I was trying not to run. I believe the original, we'll look at it. Yeah, it's about 3/4 of the way through this thing. So you may just have to come back a hair more with that. Alright. Hang tight, I want to show you guys something too with these helical gears. Alright guys, I just want to show you real quick on the original shaft. You can see at the end of that clip, hopefully you heard me. If you didn't, I'll say it again. You can see that the teeth, the cuts for the gear teeth, they protrude into this flat spot here. They're about here on mine, but they should be probably closer where theirs are. This is just a journal that a bearing race slides over against a snap ring. So yeah, the original design's like that. It's unavoidable. It's not a big deal. It's not a mistake. That's just the way it's going. So far we're doing good. We're looking pretty good. I showed you guys a little bit of my second to last pass. The last pass will be like 5 thou cleanup, and then I'll let it dig a little bit out so you get the full involute tooth profile. You know, on this last, it's like this last 1/4 inch of gear, if it's even that much, maybe 1/8 inch actually, but I want that to be fully profiled, so when I run back over it, I'll just go a little bit further than my predetermined mark. The other thing I wanted to show you, you might have noticed that, as I said in the last video, I'm dropping out of the cut. For some reason that's been disputed. And maybe on a brand new machine or a really tight, you know, not very roughly used machine, that is fine. But I'd like to show you, because I thought maybe I'd try it on my sample piece, and my machine's fairly tight. The gear train and everything, there's not a whole heck of a lot of backlash, but there is enough. I'm gonna get my hand here. If you'll notice, I gotta hold this thing up now, huh? Where can we go? Hold on. There we go. Couple. Bring it around where I want you. All right. If you'll notice the bottom side of this gear, see where the original cut came through. You can see where I reversed, and the little slop in the gear train I have, moved the entire cutter over here and made this whole tooth, well, this tooth thinner and this negative, you know, cut space, at least until here. See how it's kind of oddly shaped. You can see how it cut over. That will happen. And it did widen this and narrow this tooth. So I stand by what I said in my previous helical gear cutting video and what a lot of you guys say. It's not worth the risk. Not for me. I would recommend drop out of the cut, bring it back. I mean, you're talking heights wise. I would say you could pretty accurately get within a few tenths with at least my machine and most of your machines, within a thou. For most things that we're working on in our home shops aren't, it's not going to make and break you. And in fact, I'm relatively confident that you can obtain far greater results than that with a little bit of, extra care. But yeah, I want to show you that because I completely disagree with the idea that you run a cutter through on a helical tooth and don't drop out. And that's why. That's kind of why I ran a couple like that, to see what would happen. This was just a test piece to get the gear teeth. Honestly, I want to make sure it was going to work. I normally don't even do a test piece, but I only have one piece of metal and one shot at this, so that's where we went with that. So I'm going to go finish making this round of cuts. I'll bring you back, and then I'll probably jump in and show you maybe the last of the finish cuts, finish passes. I'm going to speed up my cutter a hair, and I'm probably going to slow down my travel speed, which is I mean, what you would do on any finish cut. So I guess I will bring you back. Alright guys, so this is our finish pass. This is end up being 4th thou, and you know, with the ball bearing measurement, we are right on with our original other side, but original shaft. So see how she looks. Looked pretty good to me. I think we might have her nailed. It's not the end of the work on the shaft, but this is the most complex part. And we'll try it out, I guess. I still need to drill a hole in the other side for the cotter pin, and then set this mill back up, zero everything out, and cut involute splines on the opposite side. So I thought I'd bring it back so you could watch the final. Alright guys, so there we have her. You see she looks pretty good. A little bit of tooling marks, but that's kind of unavoidable. At least for me, I can't seem to get rid of them. I did clean them up. I guess if I turned a little faster, maybe it look better. But you can see it's fairly straight. They're fairly superficial. And the thing, I mean, it all but matches. And this guy here, this is the reverse helix of that. Your measurements are all in spec, same. So the only thing I got to do yet is drill a cotter pin hole here and cut some involute splines. And this turkey is done. Well, I'm lying to you. There's a washer that goes here. Like that. I don't think I want to reuse this one. She's kind of beat. See that thrust pressure that a helical gear produces. Just push right through this thing. So I think we're going to try and I'm going to make one out of something I can harden. I have some 4140 sitting around. I may have a piece of 4340 that'll work, or something of the likes. Just so the gear can't eat through them. But I mean, maybe it's a bad idea. Maybe this ought to be sacrificial in nature. We'll see how hard this is, and I think that's how we're going to make our decision. But like I said, I think we got a pretty darn good jump here. And all right, take 14. I had my fan on. I recorded a few of this thing part. realized you can't really hear me. It sounds like there's a helicopter landing in the shop. So I'm gonna bear the heat for a minute. Show you what I got going on here. This is a 5/32 hole. I need to locate the center. The way we normally do that, you slide some kind of a pin in that's close to tight or on size. Measure from the end, half the pin diameter, and subtract it from that measurement, and you'll locate your center. Transferred that to this one with a vernier caliper and some hermaphrodite calipers. Eyeballed the end of the total depth of cut and the cut termination. Scribe those the same way. I did scribe a center line, okay, for our shaft, so that I can pop this in the mill, locate my center. I can use a stop that would line up parallel to our center line. I can center drill it, drill like halfway through, rotate it 180 degrees without setting a whole bunch of stuff up like a super spacer. I don't think I have a collet big enough to put it in a collet block or anything like that. And it's honestly, it's really just for a cotter pin, so it's going to be really, really precise, but it doesn't need to be. So that's that. Then we need to cut involute splines. And I just want to point out, you want to be mindful what type of splines you have, because a lot of times things that I do have involute splines, which are involuted not because they rotate like a gear would against another set of teeth, but they are for alignment purposes. A lot of times on a PTO shaft or something, or an axle shaft. Now, an axle shaft you can kind of get away with a straight cut spline, and a lot of people do with racing axles. But the involuted tooth profile allows for a slight misalignment. You know, if you have two units that are powered by a shaft and you can't reasonably line them up perfectly parallel in that axial plane, you should be using your involute splines, because the nature of that profile allows just a little bit of rock. That's the point of those. So off to the acromill to punch this hole, and then back to the Kearney Trekker, which is almost set up to cut the involute splines. And then after that, we'll turn a spacer and be done with it. Alright guys, so what I've done, I did drill the hole like I said I was gonna. I didn't get footage of it. I used that center line to get me close on my center, well, to be redundant, to double check. I have a 200 thousandths of an inch cutter, and I used a straight edge off the backside to the end, okay, and then I determined what half of that was, and I subtracted 100 thou because I used the backside of the cutter to locate. And then what I went on to do, being as this is odd, and it's maybe just a hair on the shaky side, but being as this is an odd number of splines, I can make this cut. I made a 60 thou cut, and the overall depth, checked with the pins, it was, I need 1.297, okay, 127 thousandths well thread wire is what I actually used. Being as it's odd, I don't need to cut the opposing side. It's not going to be cut when I measure it. It's going to be slot on this side, tooth on the other. So I adjusted for my final depth. It's cutting really nice, it's cutting well. It's not a very deep cut, so I wouldn't normally do it. but we're gonna give her a shot. Yeah, I'm just gonna run it and double check it, but that should give me all the way around, because everything here is set up concentric, straight, true, centered, and like I said, it's not a really deep cut, so I'm just gonna do one pass wander, finish the shaft out. You can double check at the end of this first cut before we turn it, but should be dead stick now. So let me get this one cut and I'll check it. Yeah, one more thing I want to make mention of. You guys might have noticed I don't use the dogs much. What I do is typically put a Sharpie mark right here to line up with, and these work fine, but I just have a hard time trusting them. I would rather have just a solid spot where I need to stop it, and that seems to yield good results with having a nice even looking cut all the way around a spline or gear, spline shaft or gear. So that's why I do that, and that's how I do that. So now I'm going to turn it on and make the first cut. Alright, hang tight. Couple tenths short, maybe half a thou short. I think I can live with that, to be honest with you. Good. Alright guys, like I promised you, I brought you back for the last one, and I felt real good about it. I still feel real good about it, but I'm very nervous now. I wasn't nervous until about this point here, so I guess without further ado, we'll fire the mill up, get it running, run the cut, and we'll take a peek at her. I believe that is going to be a wrap, and I'll probably just make the bushing off camera. I'll bring it back, we'll look at it. Alright guys, so went over everything's good, everything's within the specs that I figured it should be. These are, like you saw, There's what were we at, a half a thou or so deep on our cut, that's not really a big deal. I'm certainly not going to redo all of that helical stuff at that end for a half a thou, even a thou. Yeah, the holes here, you can see that was in the middle of that one exactly, and this one's in the middle of this tooth exactly, and this is in the middle of the cut, 180 out. So that's a testament to the process with drilling that hole, kind of meeting in the middle. So our drill bit didn't deflect at all. It was the whole point of that. Drag this. So there is our helical cut gear end. You can kind of see. Like I said before, note how reflective that is. You can kind of see, like here, you can see the edge of the workbench pretty straight, pretty clear. In fact, I feel like you can see that Winner's Machine Shop sticker in there pretty clear. That's because the marks that you're seeing in the light like that are superficial. If they weren't, you wouldn't get a clear reflective vision, a view of that sticker like that. But it looks really bad on camera. That's why I keep bringing it up. In person, it really doesn't look that bad. So anyhow, I think we nailed it. I think we're gonna ship it like this. Let them try it. The bearings I really can't test out. I did slide them on. They're an interference fit. They got about a quarter of the way on and got tight, which is probably where they should be. So other than that, like I recall, we had to check a helical gear with a ball bearing. We checked it, and the reason for that is the points of contact. If you were to put a gauge pin in there, it would rock. So we checked that. That's right on par with the original. Now from the other side, because like I said, this is the one. This one here is the one out of that we're replacing, and somebody has ground all the teeth off. So this was a little bit complex. Took a little bit of time. I had this. I only got the other shaft maybe a week and a half ago, before doing this job, and that kind of sealed the deal with what actually turns out were the original module is diametral pitch. Either way, it's 5. The helix angle I did adjust once I got that, because I could figure it a little bit better. Now mathematically you should figure between centers of these two axial shafts that are running in that kind of same plane. You should use that, the total number of teeth, to determine what the helix angle should be for that diametral pitch or module. But yeah, this is totally an obtainable thing, and like what I have, a home shop. And you don't need necessarily all the things that I have to do it. There's, tons of different ways to time the rotary table dividing head spinning under power at a certain speed of traverse. So a lot of people do it electronically. But I have this machine to do it, so I do it with this machine. Aside from that, I am happy with this. I am happy that it's getting out too. And I'm happy maybe now I'll be able to, I have a few more jobs to do. I need to clean this shop and get a couple things straightened out, and hopefully I can get videos more on the regular after that. Dang it, I was going to pan up to the top, but it's off right now. This is a Moore number 2 jig bore. Fortunately, after testing these spindles, well, the spindle bearings, as much as I can, they seem to be doing okay. So I try and just keep spinning it, because these have a lot of preload. If you watch DD, he points that out. These things have an insane amount of preload. You got to keep spinning them, because the balls in the bearings actually leave divots in the bearing races. So right now I can run this for 20 minutes and it doesn't get a whole lot of heat in the spindle over what it started at, maybe 15 degrees, 20 degrees at high speed. The issue I am having, everything else seems to be tight, seems to look good, seems to feel good. The Reeves drive. Okay, I don't know if I lost a sheave or what is going on, but I need to pull that apart because it was functioning just fine. You know, I would increase, decrease, increase, it went just fine. I decreased it, I increased it, it went up a couple RPM, and then just fell off, and you know, they don't move now under their own power. The motor's working and everything like that, but I got to dig into that. It's likely something stupid, a nut bolt keyway, something. Hopefully. Now, it came with a fair amount of end mill holders and a boring and facing attachment, the Chandler duplex one. So that was the payment for, I would say, too much time of my life. Yeah, trying to ascertain specs to something that was completely demolished. But I think we got it, and I don't have to move this thing one more time. I got to move it because I did. The shop is a mess. This is one of the reasons that I haven't had a video out in a while. The shop mess from moving stuff around, but I did get the surface grinder. All the grinding equipment is got my walkie stuck, or my mic wire got stuck. That surface grinder's over there, toolmaker grinder's over there. Everything got pulled out to make that happen. So this is kind of what I'm fighting with, is getting everything back into place. It's a complete and total mess, and I hate to even show you guys because it's normally not quite this, but Pratt & Whitney, long way to go on that. Haven't done anything with that because I've been so backed up with my day job, housework, side work here that needs to get done fairly quickly. Yeah, and everything else, spending time with my daughter. So I will try and get more videos out. I will try and do a better job. But yeah, this here, that's what a pain in the butt helical gear buys you, I guess. A helical gear axle shaft with obsolete splines. It's really a pain in the butt. Totally worth it. Alright guys, hopefully I got another video out before a 3 or 4 month time period. So, again, I apologize for that. And I apologize, this one was a little bit short. I just kind of decided to show you guys what I was up to and try and get back into this. Alright, thanks for watching, and hopefully I see you on the next one.